Here we want to talk about, we are still on measurements 2.3 units and standards. So we talk about fundamental quantities, derived quantities, and units and standards generally. So when we say fundamental quantities, what are fundamental quantities? They are basic quantities from which other quantities are derived. Fundamental quantities are the basic quantities of physics, and it is from all these fundamental quantities that we have the other the other physical quantities are derived from. And the units of the fundamental quantities are known as the fundamental units. Likewise, derived quantities are the quantities gotten from the fundamental quantities, as I've said. So what we are saying is that for fundamental quantities, we have 7 fundamental quantities. And it is from these 7 fundamental quantities that we have all the remaining physical quantities are derived from. What are the 7 fundamental quantities? They are length. The unit of length is meter. We have mass. The unit of mass is kilogram. We have time. The unit of time is seconds. We have electric current. The unit of electric current is ampere. We have amount of substance. The unit of amount of substance is mole. And we have thermodynamic temperature. The unit of thermodynamic temperature is Kelvin. So these are the 7 basic quantities. And it is from these 7 quantities that we have all the numerous quantities that we have. Now, derived quantities are all the quantities that are not part of the 7 fundamental quantities. Any quantity that is not part of these fundamental quantities, that is, any quantity that is not length, that is not mass, that is not time, that is not electric current, that is not amount of substance, that is not thermodynamic temperature, is a derived quantity. Now let's look at metric prefixes. When we are talking of metric scale, the SI unit is part of the metric scale. And if you look at the 7 fundamental quantities, all their units are in the standard unit, the SI unit. So now when we are talking of metric scale, we are talking of how to switch metric prefixes. We are talking of how to switch between the prefixes. So the first, we'll be looking at each prefix, the symbol, and the meaning. And the first is iota. The symbol is capital letter Y, and it is 10 raised to the power 24. What do we mean by this? We look at the base unit. For example, when we are talking of electric currents, the base unit of electric current is ampere, but we can have many other base units. Let's say, for example, we have iota ampere. Let's just see. So what that means is that 1 iota ampere is the same thing as 10 raised by 24 ampere. Now, let's say, for example, we have a meter. The base unit of length, 1 iota meter, for example, is the same thing as 10 raised by 24 meter. So we are going to look at the prefix and we look at them and connect them to the base units. That is what we are trying to do here. Now we have zeta, which is Z, and that is 10 raised by 21. We have hexa, E, 10 raised by 18. We have beta, 10 raised by 15. We have tetra, 10 raised by 12. We have giga, 10 raised by 9. We have mega, 10 raised by 6. We have kilo, 10 raised by 3. Kilo, for example, is 10 raised by 3. If we have, let's say, for seconds, the unit of seconds here for time is second. So we can have units such as kilosecond. So it means 1 kilosecond is what? 10 raised by 3 second. We have hecto. Hecto is 10 raised by 2. We have the unit of Okay, we have deca 10 raised power 1. We have yocto 10 raised power minus 24, zepto 10 raised power minus 12. We have atto 10 raised power 18, femto 10 raised power minus 15, pico 10 raised power minus 12, nano 10 raised power minus 9, micro 10 raised power minus 6, milli 10 raised power minus 3, centi 10 raised power minus 2, deci 10 raised power minus 1. So we look at all these prefix and then we relate them to the base unit. The base unit for all the fundamental quantities have been given here. So whatever prefix we look at, we relate it to the base unit because we still have to convert to the standard unit, which is the base unit. Now, one thing I need to say here is for kilogram, for mass. Of course, the standard unit for mass is kilogram, but there will be a little shift for that of mass, because when we are talking of switching between the prefixes here for mass, you will have to relate all these prefixes to gram. For example, kilo. So when you say kilo, kilo is 10 raised power 3. So 1 kilogram, for example, is the same thing as 10 raised to power 3 gram. Let's say, for example, 1 hectogram. Hecto is 10 raised power 2. So 1 hectogram is 10 raised power 2 gram. So of course, kilogram is the base unit of mass. But when we are talking of unit conversion for mass, we assume the base unit is gram, and it is from that gram that we are going to switch to kilogram. So that's that for mass. Now, the only rule when using metric prefixes is that you cannot double them up. For example, if you have measurements in petameter, peta is 10 raised power 15. So petameter, 1 petameter will be 10 raised power 15 meter. It is not proper to talk about mega gigameter. There is no such thing as that. All you need to do is switch from one unit to the base unit. It's not from one prefix to another prefix other than the base unit. You don't have to combine two different prefixes together. No. And now, 10 raised power 3 kilogram, for example, you can also write it as 1 metric ton. And metric ton is represented as small letter T. So for example, if you have 2 metric ton, 2 metric ton is the same thing as 2T. Of course, metric ton is not part of the SI system. It's not part of the SI system, but it is also acceptable for use with the SI units. So just in case, so 10 kilogram is 1 metric ton. Now, metric system have the advantage that conversion of units involve only powers of 10. In metric ton, you will see the conversion of units are in powers of tens. You can see powers of tens. That's one advantage of the metric system, and because they are in powers of 10, it makes it easy for people to actually remember. But we also have some other units that are not metric system, so we call them non-metric system, e.g. the English system. Example, inches represented as iron, and 1 inch is the same thing as 2.54 centimeter. We have feet, ft. 1 feet is 30.48 centimeter, and we have miles. 1 mile is 1,609 meter. You agree with me that these non-metric units, it won't be easy to remember them because they are not in powers of 10. So that's one advantage of a metric system over a non-metric system. Now let's look at a quick example. Convert 1.93 times 10 raised power 13 kilogram. We want to convert it to gram. So how do we do that? It is kilogram we want to convert to gram. So whatever we want to convert will be on the left side, and what we want to convert to will be on the right side. And the rule of thumb is that you start with the base unit. You start with the base conversion. The base conversion for kilogram to gram is 1 kilogram equals to 10 raised power 3 gram. So 1.93 times 10 raised power 13 kilogram now will now be what? 1.93 times 10 raised power 13 times 3, which is 1.93 times 10 raised power 16 gram. Now the second one, we want to convert this 1.93 times 10 raised power 16 gram. We want to convert it to petagram. Remember, 1 petagram is 10 raised power 15 gram. So now what is now 1.93 times 10 raised power 16 gram? That would be 1.93 times 10 raised power 15 times 10 raised power 1. And since 10 raised power 15 gram is the same thing as petagram, so it means that is 1.93 times 10 raised power 1 petagram. So that's that. Now if we look at another example, we have the density of iron is 7.86 gram under standard condition. Convert to kilogram per meter cube. The density of iron is 7.86 gram per centimeter cube under standard condition. Convert to kilogram per meter cube. As I've said, whatever you want to convert will be on the left, and what you want to convert it to will be on the right. So we can write that 7.86 gram per centimeter cube. We can write it as 7.86 gram over 1 centimeter cube. So equals to kilogram over meter cube, which is what we want to convert to. Then, what's the base conversion? Gram to kilogram. 1 kilogram is the same thing as 10 raised power 3 gram. So it means 10 raised power 3 gram equals to 1 kilogram. Since it is gram, we want to convert to kilogram. So that 10 raised power 3 will be on the left side, equals to 1 kilogram. So 7.86 gram now will be 1 over 10 raised power 3 times 7.86, which is 7.86 times 10 raised power minus 3 kilogram. Also, we have done that for gram to kilogram. Now 1 centimeter, neglect this cube first. We are still going to come back to it. It's the same thing as 10 raised power minus 2 meter. So if you now bring this back here, you have your answer for this as 7.86 times 10 raised power minus 3 divided by this 1 centimeter cube, 1 centimeter, which is now 10 raised power minus 2. Because now this cube, so everything raised to power 3. So if you do that well enough, you have your answer as 7.86 times 10 raised power 3 kilogram per meter cube. Now, that's that. Unit conversion is not always interesting, but it is very, very important because it can lead to a very, very big problem, and it has even led to problem in the past. For example, if we talk of the Mars Climate Orbiter launched by NASA in December 11, 1998, and so on September 23, 1999, they are trying to they are making effort to guide the orbiter into its planned orbit, and so NASA lost contact with it. So on investigation, they discovered that a software called Small Forces was recording the thruster performance as performance data in English unit. That English unit is pound seconds. Another software there are recording as Newton second, and so this leads to error and cause the probe to follow a different trajectory and cause the probe either to burn up in the Martian atmosphere or to shoot out into space. And because of this, millions of dollars were lost. To tell you how important unit conversion is, and everything in physics must be meticulously done. So thank you.